Howdy, this is Mr. Justice, and I'm going to show you what you need to do to be successful to complete the Surveying the Biodiversity of Pantry Food Park Part 2 lab that we started prior. So in this version, in this Part 2 rather, we're going to be calculating the Shannon Diversity Index values for those 3 different areas within our Pantry Food Park, right? And we'll get to those in a moment. So take a look here. The directions say use the highlight tool on docs and annotate the reading. Highlight and annotate. So take a look. Let me show you how to do that. So go through and take a look at this sentence right here. Biodiversity is a measure of species richness and evenness in an ecosystem. So that sounds like a pretty important concept right there. And so I'm going to select the words, come up here to my highlight tool, and then I get to choose a nice color that I can now, highlight. It's pretty cool, right? All right. So we're talking about species richness and evenness. Prior to this, we discussed how even though 2 different communities can have the same species richness, they can be very different in terms of their evenness, right? In this case of community 2, we are highly uneven in between these 2, right? Because we're being dominated by about 70% of this species of tree and community 2 versus, pretty even distribution of these proportions down here in community 1. Community 1 is highly even and community 2 is not very even. It's got low evenness. So take a look. This is the research question that we were exploring during part 1. We were calculating proportions of these 3 different areas in our Pantry Food Park, right? Plastic cutting board valley, wooden cutting board forest, and plate dry lake bed. So the research question was, which area within the Pantry Food Park has the most biodiversity of those 3 listed? And we probably discovered that the species richness of plate dry lake bed was 3, but the species richness between plastic and wooden cutting board areas is 5. So we're going to need some additional math then to determine which of these 2 areas is the most biodiverse. We're going to be able to do that using this equation, the Shannon Diversity Index value of calculating that, H. So H is representative of a diversity index that we're able to use and compare those diversity index values, one of them, with another area. And the one that has the higher diversity index value, H, is going to be the one that is most biodiverse. So take a look at this equation here. So we're going to take those proportions for each of the species within those areas that we calculated in part 1, right, P, and we're going to multiply it by the natural log of P. And with this natural log button, it's a function on our calculators. I'll show you how you can access it. What it does is it standardizes these numbers and makes them a little bit more manageable for us so that we can compare them a little bit easier. So take a look here. So this equation can be kind of confusing. And so what I've done is I've essentially taken that equation and I've organized it into a data table for us to be able to do this a little easier. Take a look at the procedures. Use the proportion numbers P for the plastic cutting board valley that you surveyed from part 1 of this lab. Use the equation, a calculator with a natural log button, and the data tables on the following pages to complete the calculations. Then take a look at procedure 3. Once you've determined H for each of the communities, compare the values and decide whether the species evenness is low, medium, or high. So what we're going to be doing is we're calculating H value between 3 different areas. Whichever one it has the highest H value will have the highest evenness. And whichever has the lowest H value will have the lowest evenness, and then we'll have one in between. So take a look at this data table here. So I've already done this where I've inputted my proportions, right? I copied and pasted those P values from my part 1 into this section here. So that's why it's already preloaded. And I've already done kind of the math here for a couple of these just because I wanted to do one with you as an example. Hey, if you get lost at any point, I've given you some hints underneath these that first number in Cheerios for Plastic Cutting Board Valley. I've kind of given you a little parenthetical that tells you where these values come from. This one, for example, comes from part 1. We determined the relative abundance of the Cheerios within Plastic Cutting Board Valley, we found that it was about 7.5% or 0.0748. What I'm going to do is I'm going to take that number and I'm going to find the natural log of it. It's a button, on our calculator, it's a function on our calculator. Let me show you what it looks like here. I've got my phone here, my iPhone, and I just want to point this out. Like, this is a 4-function calculator, but if I turn it to the side, then I'll pull up that scientific calculator function, right? Kind of cool. So let's do the one down here for popcorn. If you're looking, 0.3271. All right. So what I'm going to do with this calculator is I'm going to type that in, and I've already messed up. So let me try it again. 0.2371. And then what I'm going to do is click on that natural log button right here, and it looks like this, ln. Look for ln within your on your scientific calculator. Click that button and you've got the natural log of that button. So let's see if I can remember. 1.117. So I'm going to put that right here. And by the way, it's a negative number. Notice that. 1.117. All right, so now what we need to do in this column is multiply the proportion p times ln p, or the natural log of p, right? Remember, on our calculator, we're going to multiply p times ln p. And notice that we've got this sum here. So we're doing this for each of the species within the area. That's why we're kind of collecting these products over here in this last column, because in a moment we're going to sum it up. We're going to add it all up. Hey, let's multiply the p times ln p for popcorn, so that we can type that button in. Let me open up my calculator again. All right, and there's that number. We'll multiply it by 0.3271, and that's the number for our last column. Looks like it was negative 0.366. Yeah, that'll work. Okay, so let's do this. Now, based off of that equation up here, we're going to add up all of these numbers in that last column. So let's do that now. Let me pull up my calculator again. Oops, there it goes. Okay. Let's see. I've already got. You know what I'm going to do, because that equation here, this formula has a negative number. The reason why that negative number is there to make all of these negative numbers positive. So I'm just going to get rid of the negative number now, if that makes sense. This is kind of saving me a step here. So let's start adding these together. All right, and I'm going to take the positive versions of those numbers just to save a little bit of time, because I don't want to get confused. Let's do this, 0.368 plus, and there it is. Looks like the negative sum number was negative 1.378. And to get h, right, remember, I need to multiply that negative number times the negative sign, and I'll get a positive number. All right. So it's just, h is just that sum number, but the positive version of it. Now, I won't be able to determine whether or not this value is low, medium, or high until I've calculated the h values for the two other areas. But I'll give you a hint. What you could do is you could select, let's say this is the one that has medium species evenness. I'll select the word medium, and maybe I'll just change the color to indicate that I've selected medium. Now, if you don't have P for your areas, I'm going to show them onto the screen. So you're looking right now already at Plastic Cutting Board Valley. You can also use this to check your work too. So take a look here, right? Here's Wooden Cutting Board Forest. These are the P values, and that's what your diversity index value should look like. And finally, over here is Plate Dry Lake Bed. We've got, remember, a species richness of 3, so only 3 individuals, pinto beans, black beans, and noodles, need to be calculated, and you can check your work that way. I hope this was helpful.